Right, ready to plug it in. Now just a final quick check. It says on this little diagram here that pins 1 and 2 are ground. 1 and 2 are on the left of that connector, so that's definitely black and white. Black and white go there to cell 1 negative, so that has to be ground. So if I plug this in, I'll put the full 12 volts across this unit. This unit will power up and should be able to measure the individual cell voltages. Let's try it. Now you have to power this thing up without any PV or load attached so that it can zero out the current sensors. So I'll certainly do that and hope there's no bang. And it has powered up. I'll tip it up a bit so that we can see the display. In fact, I'll get in a little bit closer. Right, so now I'm just going to play around with it until I learn how it works. Let's just see if the buttons are responding, and they are. So we've got monitoring parameter set. Now I'm going to have to set parameters to tell the unit that it's using 2.5 volt supercapacitors, not any type of lithium cell. Device set, diagnostic and about. Let's just go into monitoring, and that is showing me all the cell voltages. And they do vary a bit, 1.428, 1.391. Now, I don't know when this device will start balancing. Delta is the difference, I think, between the highest and the lowest. 7 and 8 are highlighted, so they are the highest and the lowest. Overall battery voltage is 11.2. That's not dropping too quickly. So we've got plenty of time to sort of work through menus and stuff before I've got to apply some PV power. Now PV can actually be a solar panel, or it could just be a constant current power supply. It wouldn't really matter which way. We've only got connections for positive here. Negatives have to be connected up externally. So yeah, that's interesting. Let's go back. Oh, looks like you have to press and hold back. So let's just go into parameter set. Cell type is 6. Now I think if I just wait, some contextual help will come up to tell me what cell type 6 is, and it's LiFePO 4. Oh no, 1 is LiFePO 4, 2 is LiFePO 4, 3 is 3.6. 3 is lithium cobalt 3.95. 4 is lithium cobalt, is that oxide? I don't know, 4.1. 5 is LiCO2 4.2, so that's a normal lithium cell one would use. Now 6 is supercapacitor 2.3, and 7 is supercapacitor 2.7. Now these supercapacitors are 2.5 volts, so I probably shouldn't use the 2.7 setting. So in fact, setting 6 is actually correct. I never set that. Perhaps that's the default. Number of cells 8, that's correct. Capacity, now what does that say? 3000 farads. Now I wonder if that's the capacity of each individual cell or the bank as a whole. Now the thing is, cells in series, you have to reduce that number, don't you? So presumably that is the capacity of each individual cell. Let's OK that and come down. It's got to go quite a long way, hasn't it? Because, oops, I've only got 220 farads. So that would be there. Let's OK that. Okay. Over voltage 2.25, not sure what to set that to. Over voltage delay, over voltage, over VR, under voltage delay, under VR, not quite sure what that is. Over voltage lock, under voltage lock, end of charge. Oh, there's lots of parameters here. A heck of a lot of parameters here. This is going to take a while, but at least it's working. Right, this unit's been sitting here for a little while now. The pack voltage. The battery voltage has dropped to 10.2, so it is dropping just from what this unit is consuming. The delta, though, hasn't improved. There's still a difference of 50 millivolts between the highest and the lowest cell, so obviously this unit is not attempting to balance without some sort of supply on the PV input pins, and that's not surprising. So the next thing I need to do is put something into here. I'm just trying to think what that should be. If I use a solar panel with an open circuit voltage of about, yes, that would be about 20 volts, and these can go up to 20 volts. The solar panel could theoretically take the voltage of these things too high, but this, given the correct upper limit set, should prevent that happening by switching off the PV input. So perhaps I will use a small solar panel to charge these back up. So to continue my experiments, I've now brought the system outside. I've got the capacitor bank and the SBMS, and I've connected a solar panel between positive PV and just system ground, so that's there. So the solar panel now has the ability to charge the battery bank, but through the SBMS. So the SBMS has the option to switch the PV off, I presume, if the various voltages get too high. Now this solar panel is about 15 watts, so that's going to be able to generate in the ballpark of about an amp. So let's see what happens. Now we've got sun at the moment. Nothing's happening. The voltage has gone up because I did switch on the solar panel. Now it seems you have to press load, and at the top there was a message PV and load on, and now we can see that the battery voltage is shooting up, that bottom right hand parameter, and now the upper voltage was set to 2.25, so that would be 2 times 8 is 16 plus a quarter time, so that's 18 volts. This thing should go up to 18 volts before the SBMS decides that the capacitors are over voltage. So I'll let that, the sun's quite strong at the moment, I'll let that head on up to 18 volts. You can see that the state of charge indicator at the top there is also climbing up, 35–36%. The delta though is not changed at the moment, and I'm just wondering whether that's because it doesn't actually start balancing until at least one of the cells has hit its maximum. So I'll just leave that for a while until it gets a little bit nearer to that 18 volts. In fact, I found another screen here. If I press the up button, I can see the current flowing. That's a plus just before the 0.9 amps. So 0.9 amps now at 14.4 volts, and you can see the individual cell voltages, and there is a little bit of discrepancy between them. I think I've locked the exposure. Let's unlock the exposure. No, I haven't locked the exposure. Just not having much luck filming the display at the moment. Right, the sun's just gone behind a cloud, and you can see that the current has immediately dropped to nothing. So it's not charging now, or is it? 14.7879. Is that going up or down? It might just be providing just enough current to offset the draw of the SBMS itself. Possibly not. That looks like it might be falling ever so slightly. So I've got to wait for the sun to come out again. Well, it looks like it will come out again when we get that bit of sun, but not for 5 minutes or so. Right, the sun's out again. The voltage is up to 17 volts. Now some arrows have appeared next to certain cells. I presume it's the high cells. I wonder if that means that the balancing circuitry has been invoked. I don't actually know. The delta is sometimes dropping, but sometimes high. I think the sun's dropped now sufficiently that it's not charging. Oh, I can feel the sun warming up again. Yes, I'm not entirely sure what's going on, but I assume those arrows are the balancing circuits in play. Well, now the sun's out quite strongly and it's no longer charging. You can see that the total voltage is going down, and I assume that's because the MOSFET connected to the PV input has turned off. Now, there are other monitoring screens. See if I can touch that button. Those are the battery voltages. Yes, I think that said there was no current. It's hard to find the keys while I'm doing this. Yeah, 0 current flowing in. Well, that's fine. Now, these are the flags, and you can see that the defect flag at the bottom right is highlighted, so I assume that the discharge FET is turned on. The C FET, that's bottom left, you can't see the C because of the shadow there, but that's the charge FET. That, I assume, is turned off. And the flag top left, which is overvolt, if I tip that up you can see that that's overvolt, that has come on, so maybe the unit's gone into overvolt, and it won't reset that flag until you get to the voltage at which the cells are ready to be restored. Now let's go back, go down to parameter set, OK that. You can see there that the overvolt is 2.25. If I come down, that's the overvolt restore, 2.05. So I assume until they all get down to 2.05, they won't start charging again. Now you can see that the bottom line has some context help. Over voltage recovery, and this is what I like about this operating system. If all cells, that could go a little bit faster I suppose, fall below this, the charge FET is turned on, I presume. Turned on. Yeah, so if all cells get below 2.05 volts, the charge FET's turned on and they will start charging again. They haven't balanced yet though. Now it should start charging again soon because, oh, I think it did. The bottom right voltage dropped below 2.05 and that was the highest voltage. That's now charging, and maybe now it's not charging again. There's no indication on this screen of whether the charge FET is switched on or switched off. I don't think. Right, I'm now in the screen where you can see the charge FET and the discharge FET status. They're both on, so it would in theory be charging, but it's not because the sun's disappeared. Yeah, a huge grey cloud has appeared. I mean, it's nice and sunny over there, blue sky there, but not here, I'm afraid, so we wait. Well, while I'm waiting for the sun, let's flip through all the monitoring screens that there are. So those are the cell voltages, those are the cell states of charge and overall state of charge, current and voltage. Then you've got a current bar graph, that's sitting at 0. I don't know what TI is, 623 millivolts. That looks like a similar number to the delta. And TE, 537B, not sure what that is. Those are the flags. The charge FET is on, the discharge FET is on. What else have we got? Battery voltage, current, power, amp hours, watt hours. PV, current, power, amp hours, watt hours. But battery voltage, not PV voltage. I suppose you can't measure that. Well, it's the same as the battery voltage, I suppose, if the MOSFET's on. Battery voltage, load current, load power, load amp hours and watt hours. And then back to the individual cell voltages. Still no sunshine, I'm afraid, so I'll carry on waiting. Now I've hooked up a load. This is a 24 volt truck bulb, 24 volts, 21 watts. So I can connect that load to the load output by clipping that on there, and if the discharge MOSFET is switched on, in other words if the battery voltage is high enough to support drawing a current, then that lights up. If that brought the battery so low, and you can see the percentage with that bulb on dropping down 77, 76, 75, at some point the undervoltage parameters would kick in and the load MOSFET would switch off so that you could no longer draw a current from the battery. Right, I think the sun is just coming out, so let's watch the battery state of charge percentage, 85%. Now I'm expecting when that gets towards 100, sun's a bit stronger now, the overvolt flag will come on, that's top left, and the charge FET will go off in order to prevent overvoltaging the battery pack. 90%, sun's still out fortunately. 91, so EOC, I wonder what that is. End of charge? Don't know. We haven't got the overvolt flag lit yet. 94% is that? 95. I can feel the warmth of the sun on my head, so it's getting stronger. 97%. Just waiting for that overvolt flag and the charge FET to go off. 98. So 100%. Will the charge FET go off? Unfortunately, you can't see these FET flags and the battery voltage at the same time. So I've got a notional 100% state of charge, but I can't actually see what the battery voltage is. I suppose I could look up my DVM, and there it goes, it's gone into overvolt. The charge FET has gone off, so the solar panel has been disconnected from the battery pack, and presumably the battery voltage is falling back down again. And there is the battery voltage, it's on the next screen, and yes, it's trickling down. 17.55, 17.55, and there's no battery current. That would have been showing some current, presumably when the charge FET was on. Well, this is good fun, isn't it? So let's connect the load, which is that bulb. The bulbs come on. That quite quickly pulls the voltages of the cells, the voltage of the battery, which you can see bottom right, down, and when we get to below 2.05 on cells sort of 3 and 7, 2.04, 2.05, I think that's, oh no, 2.06 on cell 6. Right, I think they've all gone below 2.05, so it should have switched the charge FET back on. Let's have a look at that. And there it is, charge FET is back on. Don't know what EOC is though. So, I mean, this is great fun, and because the supercapacitors have a relatively small holding charge, things happen quite quickly, and you can see you know, the input side of this thing and the output side of it switching on and off. I'm going to have to set it up in the workshop though, using some sort of power supply as a pseudo solar panel, because the sun is just not playing ball today. It's gone in again, no sunshine on the panel, and so it's very difficult to do these experiments in real life. But I think if I set up one of those power supplies where the output can be higher or lower than the input, I could make that a sort of pseudo solar panel and do some real proper testing of this on the bench. I just thought I'd see if I could get the discharge FET to switch off. The undervolt setting in there is 1 volt, so that's 1 volt per capacitor, so it would have to drop down to 8 volts before it switched off the discharge FET and therefore disconnected that load bulb. So it's got a fair way to go. Perhaps I'll just leave it for a bit. There's no sunshine. Right, that bulb's got quite dim now because I've let the capacitors drain down to 8.3 volts, but when that gets to 8, that should shut that bulb off. Let's just see if it does. Oh, it did slightly above 8, didn't it? And as a result, because the load has been disconnected, the voltage on the capacitors is now holding reasonably steady. In fact, it's climbing up ever so slightly. It's just some sort of recovery thing. It won't climb up for long, I wouldn't have thought, because the SBMS is still drawing a current, but it is recovering ever so slightly. But yeah, the discharge FET did turn off and that lamp has gone out. You can see that the undervolt recovery, the bottom one there, is 1.2 volts, so with 8 cells that's 9.6. So let's see if the bulb switches back on when the battery reaches 9.6. Well, it's climbing, but it's climbing extremely slowly because there is no sun, and I can't see any sun on the horizon now. It is climbing, sort of. See if that cuts back in at 9.6 volts. Possibly a little bit of hazy sun. Bit boring this, just gonna have to wait. Would have been quicker if the sun was out, but no such luck. Will the load switch back on at 9.6 volts? There may be a bit of a margin, possibly. Quite a large margin by the look of it. The sun's coming out, but the panel is part shaded now. Well, it hasn't come back on at 9.6. 1.2 times 8. That's 8 times 0.2 times 8, which is 16, yeah, 9.6. I'm not sure why that hasn't recovered. Maybe it requires individual cell voltages to recover. Well, they're all pretty similar. I'm going to have to move the panel. It's climbing too slowly. Have I miscalculated? It's up to 10.6 now and the discharge FET still hasn't switched on. In fact, I can check that in one of these other screens, the flag screen. Nope, the discharge FET is still off and the undervolt flag is on. So I must have got that wrong. I'm not sure quite when that's going to come back on. Well, the context help just said if all cells rise above this voltage 1.2 and there is no load, then the FET turns back on. So maybe it senses that there is a load. I'll need to take that load off and then put it back on. Yes, indeed, it sensed there was a load, so it hasn't turned the discharge FET back on by temporarily removing the load. And there is no load, it says there. That has come back on, so yes, that's interesting. That works. So that's really interesting. Hazy sunshine now, so the capacitor bank is charging back up. But this is a hugely powerful interface. You can control pretty much every parameter, undervolts, overvolts, times related to those, the distance between those cutouts and the recovery voltages, because you don't want them the same, of course, otherwise you'll get flickering, so there's some hysteresis in there. But everything is adjustable, everything is configurable. It's just a really powerful system. The only thing I haven't seen today is the delta voltage go to almost zero. I mean, maybe it doesn't go to almost zero. Maybe the delta voltage or the system that balances the cells is configurable. I don't know yet. There's a lot of parameters in here, so I'll keep playing with it, but probably not outdoors and probably not with real sun, because there isn't any. So for the moment that's it. That's all my playing for today. Now, because I've got this other ribbon cable, at some point I'm going to thread this in and around the 8-cell lithium iron phosphate pack that's in my electric bike battery, so that I can then set the SBMS to its lithium iron phosphate setting and use it to charge the electric bike battery with a much bigger solar panel, of course, not this little 15-watt one here. But that's for another day. So for the moment, cheerio.